Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Exploring the Fibonacci sequence and its presence in the universe. The Fibonacci sequence is a series of numbers in which each number is the sum of the two preceding ones, starting from 0 and 1. This sequence 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on, has captivated mathematicians, scientists, and artists for centuries due to its fascinating mathematical properties and its prevalence in various natural phenomena. The significance of the Fibonacci sequence extends beyond pure mathematics. It permeates nature, art, and the cosmos, providing insights into the underlying order of the universe. The Fibonacci sequence was first introduced to the Western world by Leonardo of Pisa, an Italian mathematician known as Fibonacci, in his 1202 book Liber Abaci, the Book of Calculation. Fibonacci's work popularized the sequence in Europe, although it had been previously described in Indian mathematics, particularly in the work of Acharya Hemachandra and other scholars. Fibonacci's formulation arose from a problem involving the growth of a population of rabbits, wherein each pair of rabbits produces a new pair, and these pairs begin reproducing from their second month onward. This problem led to the sequence we now know as the Fibonacci sequence, where each term is derived from the sum of the two preceding terms, creating a recursive relationship that generates an infinite series of numbers. One of the most intriguing aspects of the Fibonacci sequence is its connection to the golden ratio, denoted by the Greek letter phi. The golden ratio is an irrational number approximately equal to 1.618. As the Fibonacci sequence progresses, the ratio of consecutive Fibonacci numbers converges towards the golden ratio. The golden ratio has been studied extensively for its aesthetic and structural properties, appearing in art, architecture, and various natural forms. It is often associated with beauty and harmony, as its proportions are found in the Parthenon, the pyramids of Giza, and many Renaissance artworks. In nature, the Fibonacci sequence and the golden ratio manifest in numerous ways. One of the most well-known examples is the arrangement of leaves around a stem, known as phyllotaxis. Many plants exhibit spiral patterns in which the number of spirals corresponds to Fibonacci numbers. This arrangement allows for optimal light exposure and space utilization, demonstrating an evolutionary advantage. For instance, the number of petals in many flowers is a Fibonacci number, and the arrangement of leaves or seeds in a spiral pattern often follows Fibonacci numbers to maximize efficiency in packing and resource distribution. Similarly, the Fibonacci sequence can be observed in the arrangement of seeds in a sunflower, the branching of trees, and the pattern of pine cones and pineapples. These natural occurrences suggest that the sequence may be a fundamental principle in the organization of biological structures. The presence of the Fibonacci sequence extends beyond terrestrial biology into the realm of astronomy. Spiral galaxies, such as the Milky Way, often exhibit logarithmic spirals that are related to the golden ratio. These spirals can be described mathematically by the Fibonacci sequence, suggesting that the same principles governing the growth of plants might also influence the structure of galaxies. This raises intriguing questions about the fundamental nature of the universe and whether certain mathematical patterns are inherent to its fabric. The arms of spiral galaxies follow a logarithmic spiral pattern, which can be related to the golden ratio. This indicates that the same principles that create beauty and efficiency in natural forms on Earth also operate on a cosmic scale, governing the structure and dynamics of galaxies. In addition to its presence in galactic structures, the Fibonacci sequence also appears in the study of wave patterns and acoustics. For example, musical scales and the frequencies of notes often follow ratios related to Fibonacci numbers. This connection between mathematics and music highlights the sequence's role in creating harmonious and aesthetically pleasing structures, both in art and in nature. The Fibonacci sequence appears in the spacing of harmonics and sound waves and the structure of musical compositions, providing a mathematical basis for the perception of harmony and beauty in music. In the realm of quantum physics, researchers have explored the presence of the Fibonacci sequence and the energy levels of certain systems. The study of quasicrystals, structures that are ordered but not periodic, has revealed that they can be described using Fibonacci sequences. These discoveries suggest that the sequence may be fundamental to understanding the organization and behavior of matter at the smallest scales. Quasicrystals, which exhibit a form of symmetry that does not repeat periodically, are often described using the mathematics of the Fibonacci sequence, indicating that these principles may govern the arrangement of atoms in these unique materials. Moreover, the Fibonacci sequence is also observed in the branching patterns of trees and the arrangement of leaves along their stems. The number of branches at successive levels of a tree often follows Fibonacci numbers, ensuring that each branch has optimal access to sunlight and air. This pattern can be seen in many species of trees and other plants, indicating a widespread evolutionary strategy to maximize resource acquisition and growth efficiency. The Fibonacci sequence's ubiquitous presence in natural and cosmic phenomena has profound implications for our understanding of the universe. It suggests that there may be underlying mathematical principles that govern the formation and behavior of complex systems, from the growth of plants to the structure of galaxies. This raises philosophical questions about the nature of reality and whether mathematical patterns are discovered or invented. If the Fibonacci sequence and the golden ratio are fundamental to the structure of the universe, it implies that the cosmos operates according to deeply rooted mathematical laws, which we are only beginning to understand. In conclusion, the Fibonacci sequence is more than just a mathematical curiosity. Its presence in a wide range of natural and cosmic phenomena highlights the interconnectedness of mathematics, biology, physics, and astronomy. By studying the Fibonacci sequence and its manifestations, we gain insights into the fundamental principles that shape our world and the universe. This exploration reveals the elegance and complexity of the cosmos, reminding us of the beauty and order that can arise from simple mathematical rules. As we continue to investigate the Fibonacci sequence and its role in the universe, we deepen our appreciation for the intricate patterns that underlie the fabric of reality. Through this lens, we can begin to see the universe not just as a chaotic expanse, but as a realm governed by harmonious and mathematically precise principles, where the Fibonacci sequence serves as a bridge connecting the microcosm of atomic structures to the macrocosm of galactic formations.